Okay. So far we have looked at the basic data types which are available in C. Okay. We also, the basic data types that we have seen are integer, float, double, etc., char. Okay. After that, we also saw a derived data type, right? So derived data type is an array. So basically, it's using the primitive data type and it is creating another type out of that, and that is an array. Okay, so array could be of integers or characters or floats. Now, um, next we move on to another type of derived data type. Okay, which is also typically called a user defined data type. Okay, so user defined data types that we can have in C. Okay, typically these are two types, and why are they required is because, like an array, we saw the usefulness of an array where we can actually look at refer to multiple such integer, multiple such floating point numbers at once. Okay, with a common name, so that our programming becomes easier. Similarly, when we are to look at record types, for example, if we are looking at an application where we want to model maybe a user of any portal, web portal, or any app that we are having. So in that case, the user is going to have different parameters which need to be saved. So the records of users are saved in the database. So you have a backend. So logically, you can have a user which is a type which will have different fields or components like the user ID, the user name. Okay, all such. Hello.
Ma'am, are you talking about struct?
Yeah, I am coming to it. So for doing this, so for doing all of this, you need a user defined data type so that you can logically refer to all data pertaining to a single user with a single name. Okay. So in C, there are two which allow you to have user defined data types. One is a struct, okay, which is a structure, which is a short form for a structure. And second is a union. Okay. A struct and a union. So these are user defined data types which are provided by C. Okay. Now, since they are user defined data types, uh, the difference between structures, unions, and arrays is that arrays you can have similar types, right? Only or the same type uh, we have, that is integers, arrays of integers, or array of characters, or array of floats. Okay. On the other hand, the structures and unions allow you to combine multiple types. Okay. So arrays and structures and unions allow you to combine multiple uh, data types which are there in C. So let us see what is the syntax of defining. First of all, we will talk about structures, then we'll talk about unions. Okay. So when we talk about structures, the syntax of structures is struct, the keyword struct followed by the structure name into curly brackets. You have the different components of the structure. So for example, okay, let us say, so we call these components, so I'll just write component list. We call this component list or member list. These are members of the structure. Okay. And then followed by a semicolon. So here you are defining a type. So to give an example of this, suppose I'm creating a user structure for a user of us, and I want to model the login scenario. So I'm just looking at the login. So in that case, I say struct user, I give it a name, and I say user ID and password, right? What will be the two components of the user? The user ID and the password. So user ID is a string, say maximum 20, and password is a string. Okay, it could be 15. This could be 15, whatever you decide. Okay, and this is one example. Now in this example, I've used character arrays only, but you can have a combination of types. So for example, I have a structure to save the personal data of the user. So in that case, maybe I have some combination, or I'll choose some other structure. Say I choose country. I want to model country. So when I talk about country for a particular application, a country will have the name of the country. Each country will have a name, right? Maybe 20 characters or 25, whatever you want. Then the country might have, you want to consider the population. Okay. So what is the population of the country? And a country will have the national language. Okay. That it speaks, that its people speak. Okay. So here this is an example of combination of different data types which are there. Okay, this whatever you have written right now, whatever I've written right now is nothing but the type. You have defined a user type using structure. Now if you want to create a variable of, so whenever you have a type, you create a variable of that type to use it, right? So once you want to create a variable. For creating the variable of the type, what is the syntax in C? For example, for an int, it is type name followed by the variable name, right? So similarly for here, for the structure, the syntax is to define a variable. So to define a variable, it is type name. Type name here is struct. For example, for the first one was struct user, and the
Variable name.
name is maybe user1. Okay, struct user1, because the type is struct user. Type of user1 is struct user. Similarly for country, it will be struct country, country1. Let me say C1, C1, C2, C3. You can create any number of variables. Okay. Now this is fine. I create variables. Now if I want to assign or access each individual component of the structure, each individual member of the structure, then in that case, what do I do? How do I access it? So to access each component of a structure, I make use of the dot operator or the period operator, the dot. Okay. So I say variable name. So suppose I want to access user1's UID, then I say user1 dot, what did I name it? U underscore ID, right? So if I want to access it, I say user1 dot U underscore ID. Okay, so the dot operator is to access the individual components. If I want to access countries, country C1's population, so I say C1 dot population. Okay. Next, can I create arrays of these structures? Yes, I can create arrays of the structures. So how to create arrays of the structures? Simply like you create array of a variable. I say type, okay, array name. Let me call my array name as users. And I want to create an array of 10 users. So I say into brackets 10. So this will create an array of users. Similarly for country. Okay. So this is about creating arrays of structures. Now, the next thing is if you want to read data into these structure variables, then you have to make use of the dot operator one by one to access the components and read into the components one by one. Okay, so let us take a simple example for understanding this. So we'll just go through a simple flow through the structure. So to understand how to read data, how to write into a structure variable, and how to manipulate a structure variable, we'll take a simple example of let us take the example of complex. I want to create a structure which represents a complex number. Okay, so structure complex. So what is a complex number? A complex number has two parts, the real part and the imaginary part, right? So our structure will contain these two components, right? Now, if I want to, what all operations? Okay, first of all, I want to have functions to read a complex number, to print complex number. Okay, I will write these functions so that this will give you a first-hand experience of using structures. Then we also can perform some operations on complex numbers. What are the operations that we can perform on complex numbers? Let us take the basic operations. We can add two complex numbers. We can subtract. Okay. We can multiply. Let us take three. You can add the others. What others are possible? You can find the absolute of a complex number. Yes. Complex number सबको पता है ना? What is it? Real plus I imaginary, right? So we will model this using the complex structure. So what other operations you can perform? Complement. Okay. So let us complement of a complex number. So let me leave these two for later or for your exercise. Let me first write these five functions. Okay. Something happened, the M shifted here. So let me switch on to my editor where we'll write the program. Okay. So first of all, if I'm writing this program of complex numbers, first of all, let me include, okay. And where do I define this complex type? I define this complex type outside main. Remember that this because I want it to be accessible by the functions which I define. My functions which I'm going to define are read complex. Let me call it read complex. Okay. One is read complex. Next is print complex. Okay, and add complex, subtract complex, multiply complex. Fine. So these are my functions. Now these functions are going to work on the complex type. Okay. So here, first of all, let me create the complex type. So I say double, real. I'll use double. You can use float. Okay. Imaginary. Now, if you want to read into this, uh, we'll use the read complex function. So how will the read complex function look like? What will be the prototype of it? It's going to return a complex type, because this function is going to create a complex variable inside it, and it is going to return a complex type. So the return type will be struct complex. Why should it return this complex type? Because in main I will call this read complex function, right? So in main I will have two variables, x comma y. Okay, these two variables I'm going to read one by one so that I can perform the operations, because if you look at all these three operations, these operations require two complex numbers. So I need to read two complex numbers one by one. So read complex is going to read a single complex number, so you have to call it twice, once for reading x and second for reading y. Okay, so then inside this I say, so read complex will have a complex variable. Okay, so let us say t. So I say printf enter real part. Okay, and scanf. So now comes the thing of reading it. So how do I read it? What's the type? The type is double. So %lf. Now I want to read the real part. So how do I access it? Do you recollect? I just mentioned t dot real.
Real.
But it is scanf, and scanf for double. So it will be address of t dot real. Fine. Scanf, right? It's not printf. Similarly, enter the imaginary part. And here I will replace it with t dot imaginary. Now once I read it, I want this function to return my t, return the t, whatever that data is entered, that has to be returned. So I say return t. So this function is going to return my read one complex variable into t and return t. So that whichever function is going to call this read complex function, that function will be able to read a variable. Okay, so since it is returning t, how will I write it here? I'll say x is equal to, how will my call be here? X is equal to read complex, right? Similarly, y is equal to read complex. So my two complex variables have been read using this. Similarly, for print complex, what should be the parameters? Tell me, what should be the prototype of
Ma'am, can
print
you
complex?
explain the return type struct complex? Hold on.
Return type?
Why did
I
you
didn't get
write
your.
return type
Ah,
struct complex for?
hmm. Okay. Usually, whenever you return a value from a function, like for example, if you want to add two numbers, so what is the prototype? It will be, suppose it is float, so it will be float add. It is float a comma float b. Okay, or suppose you want to return, fine. Then you have your, how will you define it? It will be float result, and say I'm just using, so then result is equal to a plus b. Okay, and return float or return res, right, result, because this function is computing something over a and b and it is returning the result. Okay, This is how you write it. Similarly, in case of read complex, I need to read a number into some variable and I need to return it back. Return that variable back. That variable now happens to be a complex struct type, right? It's a user defined type. It's not a normal type. So if in that case it's similar, na? I just say struct complex t, and that t now t dot real will you are getting real the real part, t dot imaginary you are getting the imaginary part, and t is now having both the real part and the imaginary part. So both you are initialized. You have initialized real and imaginary. Now this t has to be returned to that function. Otherwise, what will happen? If you remember, this is a local variable. T is a local variable of this function. If I don't return this t, what will happen? I will not get this t back. Na? It will remain here only. It will vanish here. I will not be able to extract it in main. So I need to return it. So that is why I'm returning it. And return type is a similar analogy with this. Does this answer your question?
Yes, ma'am.
Okay. So next is about printing. If I want to print a complex number, what do I need as an argument? First of all, it's printing the number, so I do not no return type. I do not want to return anything. This function will print it. So what do I need here? The complex number, right? I need to pass as an argument to print complex the complex number itself. Yes or no? So I say
Yes, ma'am.
struct complex and the complex number. Okay. And then I say so how will I write it? T dot real comma T dot imaginary. Okay. So here I will simply say print complex. Print. How will I call it? It's not returning any value. So directly function name. Suppose I want to print x, I say print complex x. Suppose I want to print y, I say print complex y. Fine. So that is about reading and printing. Everyone is clear about reading and printing? Okay. Now next is for adding. For adding two complex numbers, what do we do?
We add the real parts and imaginary parts.
Yes. So what will be the prototype of this function? First of all, it will take two parameters. Each of these function will take two parameters. What are the two parameters? Two numbers, any two numbers. So let me say C1 dot me, comma, right? Are you getting the difference? Now you should be correlating this with the functions that you have studied. Function, user-defined functions that you have studied. You usually say int a, comma, int b, or whatever, float b, whatever. Now it is struct a, struct complex C1, comma, struct complex C2. Are you getting it? Are you able to correlate it?
And the return type will also be struct complex, no?
Yes. So this function is going to return what? The complex number. So the return type will be struct complex. Very good. So now here what you're going to do, you need to add the real parts and you need to add the imaginary parts, right, of the two numbers. So but you need a result variable, like in this example, adding, right? That is why I kept this. So you need one variable inside the function, and the type of that variable will now be struct complex. right? Same analogy. Struct complex, result. Result. Now, on the left hand side, you will have the real part of the result. So you'll say result dot real is equal to C1 dot real plus C2 dot real, right? And result dot imaginary image is equal to C1 and simply return result. Correct? Similarly, that the same idea about goes for subcomplex. Only thing is the sign will change, right? What about multiply complex? How do you multiply two complex numbers? Of course, return type will be same. How do you multiply two complex numbers? Open the brackets, right? So how do you do it? C1 C1 dot real, you multiply it, right? Open the bracket. So it will be C1 dot real. What will be the real part of the result? If there are two complex numbers, C1 dot real plus it is I C1 dot imaginary. Okay, C1 dot imaginary. I C1 dot imaginary. This is first, right? What is the second one? I'm multiplying this with the second one. It is C2 dot real plus I C2 dot imaginary, right? These are my two numbers. I open the brackets up. I say C1 dot real multiplied by C2 dot real. Okay. Then
minus C1 dot
C1 minus.
this will be minus, see, because I square, right? I into I square. So minus C1 dot imaginary into C2 dot imaginary, right? This is the real part of the result, and the imaginary part will be, you multiply this with this, the
C1 real
opposites. I mean,
imaginary.
this, yeah, this imaginary with this real, and this real with this imaginary, right? So that will be C1 dot real into C2 dot imaginary, okay, plus, there'll be plus here, right, inside, C1 dot imaginary into C2 dot real. So this expression that we have, so this is the real part, this is the imaginary part. This expression we have to write inside. So the resultant real part is this bracket, okay. So we'll just write this bracket, C1 dot real into C2 dot real minus C1 dot imaginary, sorry, I took the real L off here, into C2 dot imaginary. Okay. Similarly, the imaginary part, C1 dot real into C2 dot imaginary. This will be plus C1 dot C1 dot real, C1 dot imaginary into C2 dot real. Right? So this is our this complete struct complex, multiply complex. So now we'll call these functions one by one. So we will say, now since it is having a result, we can directly write it inside printf. Okay, but for writing it inside printf, it will be I cannot write it inside printf because my in order to print the complex number, it's not a simple type, remember. So I have to make use of the print complex function. I have to make use of the print complex function. So what do? I cannot write it directly. So what do? First of all, I will have one variable result here. Okay, and this variable I'm going to use one by one, and then I'll use printf. So r is equal to add complex x comma y, because x and y is already read now, and then I say printf. Okay, addition is I will call that print complex. Print complex. In order to print r, I need to call print complex function. So I say print complex r. Okay. Then similarly for the other options. So r is equal to subcomplex subtraction. I'll have to add new lines. Okay, and similarly multiplication.
And would we have to use different struct complex variables for these subcomplex and multiplication?
You can use, I'm reusing it. That is why I have to write it in this order. No? Otherwise, if you're using different variables, I can write 1, 2, 3, the calls one by one, add, sub, and mul, and then I can print.
Okay.
I'm reusing the variable. That is why I am writing it in this fashion. Multiplication. Okay. So this is about let us run it. Okay, I'm not sharing it. Okay. Okay, now because I have not used new line for this, for the printing of this, I have not used new line there. That is why it is printing to it. So it's giving me the correct. See, what I've done is I've called the read function twice for x and y. Then I've called the print function for x and y. So 3 plus I4, 2 plus I. Now Addition is correct, right? Subtraction is correct. Now, if I want to multiply, see real into real minus imaginary into imaginary. So that is right. 3 to the 6 minus 12. That is minus 6. Okay, so this is how it works. You can also make some changes like if this is negative, then if you want to bring that negative out, then you'll have to write that in that fashion, the printf. Are you getting it? If the imaginary part is negative, then what changes will you make to the printf function? If you want that minus sign outside, you have to tweak it a bit. You have to you have to tweak the print complex function. This print complex function, I've directly put plus sign in between. But if I want to tweak it so that to accommodate the negative imaginary part, then I just have to say if uh, this is minus, if this is negative, then I'll write it as this minus this. Okay, correct? Is this clear? Is this example clear?
Yes, ma'am.
So
Ma'am,
this is
can you repeat
about,
for minus?
yeah, if you want to bring, so for example, instead of minus 6 plus 17, you add 6 minus 79. So it would have, how would have been it been printed? 6 plus I minus 17. It will print like that, right? So this minus sign, suppose you want to bring it outside, you have written a static printf inside this. In print complex, you have written simply real plus I imaginary. So if I want to bring that out, I will simply check the imaginary part. If it is minus, then I print the minus sign. If it is positive, then I print the plus sign. So it will be if I t dot image is equal to is less than 0, then I will put the minus sign in between. Okay, then you can even customize it further. What can you do if the real part is 0, if the imaginary part is 0? That also you can write those conditions, if else, and then finally this. Okay, so printing can be made complicated. Are you getting it? See, when I give you this program, you should go and change it. You should try different things. You all are not doing that. You just take it as it is on face. You should manipulate it and see how it is changing, what all changes you can make. Okay, so that is your post lecture practice or post lab practice that you have to keep on doing. Once you do that, you will get good at this. Fine. So this is about complex. Now let us see one example of so everyone has understood now how to pass a simple variable to functions, how it will return that the complex variable, the structure variable to a function, and how it returns also. That also we have seen. How to use in scanf, address of with the dot operator, right? How to print, everything we have seen. Now,
Ma'am,
yes,
ma'am, in the print complex function, you initial the arguments were complex t only, and then
yes,
afterwards you used the dot operator. So,
yes,
ma'am, we can use the dot operator to bifurcate into any number of variables we can, like you did for t dot real and t dot imaginary. If we add a vector, 3D vector, so t dot I, t dot j, t dot k, we can do that, no?
yes. It depends on how many ever components you have defined. So if there are 4 components, like for example, in the country, we have 3 components, right? In this, we have 3 components: name, population, and language. So in this case, it will be t dot name, t dot population, t dot language. Only thing is, since it is name, you have to use string copy, strcpy. Okay, if you're using scanf, then it is fine. You can do a %s. Okay, but if you're doing an assignment kind of stuff, then you will have to use strcpy. Remember, these will be strings for this.
So, ma'am, in vector we have to define like int I, int j, and int k. in the struct
So it will be
content.
t dot I t, yeah, int I comma j comma k also, because if they are of the same type, like in this, I showed this, even for complex. In complex, let us see, these components of the same type, then I can use a comma, na? But
Yes,
if they
ma'am.
are
Was
different types, then I have to use a separate declaration. One is int, one is float, one is double. Then I have to use different. Otherwise, I can use comma. It's similar to what you have done. Only thing is from main you have put it up, picked it up and put in complex. That's the only thing. Okay. Now we will move on to one example on array of structures. So we have seen simple variables of user defined type, structure type. Now we will see an example of array of structures. So for that, these are the two problem statements, by the way, which you have to perform in the lab session. So we will look at one problem statement. The first one, that is for the airline reservation system. Okay. So for this airline reservation system, we have to maintain records for the flights and the possible flights, and the records consist of these components: the starting point, the destination, starting time, arrival time, and seats. Okay. So once you have defined this structure, so this will be a structure. Okay. So once you define this, what we will do is your program has to read 20 such records. Now, so usually you're going to not deal with some single variables like this, but multiple such records. Okay, so 20 such records followed by queries of the form starting point dash destination one to align. Once, so basically, once you create this, you have to create an array of structures. Once you define this type, you create an array of structures and read into that array. So now for simulation, instead of 20, let us just go for 4 or 5. Let us write a function which will read 5 such records, okay, into the array. So basically what you need to do is, first you define your structure, then you define your array of structure, and that array of structure you pass to a function. You pass to a function. You know how to pass an array to a function. So we'll pass that array to a function uh, which is going to read all these records for these 5 different flights. Okay, these records of flight details. Then after that, we need to also take queries of the form starting point to destination. So we need to book a flight now. So the flights are available. This is the record of flights available, records of flights available with us. We need to check for booking. So some queries asked, okay, from this starting point from Mumbai to Delhi. So is there a flight available or not? So we have to take these queries one by one. And for each query, you have to find whether there is a possible flight with a seat available. So if it is available, then you reduce the seat by 1 and you print out that the flight is booked. Otherwise, if it is not available, then you say it is not available. Okay. So for the simulation purpose, you can keep some seats as few for a few flights, or you can keep one of the flight seats as 0. That is, the bookings are done. So that flight is not available, just for the simulation. This is basically simulating that booking system. It's on a very superficial level, this question. Okay. Where we are just, ignoring a few things, technicalities, and we are just looking at how to deal with arrays of structures. So first of all, let us create this structure. What is that structure? Okay, let me call it flight. Then starting point, destination, starting time. These are the 5 components or members of the structure. let me write. So first two are strings, right? 3-character codes. So for example, Mumbai to Delhi. So MUM will be for Mumbai, right? Mumbai to Delhi, like this. So uh, starting point, let me call it SP just to make it quick. Okay, I'll be, since it's 3-character codes, I'll make a string of it. It will be easy for me to compare the strings, right? I can use strcmp for comparing because I need to search through my records also. Na? The second part is to search whether that flight is available. So I need to make a comparison for the starting point and the destination. Okay, so and that is why I'm making it a string. So since I'm making it a string, the 3-character code will be converted to a 4-character array, right? Because the last character will be a \0. Are you getting it? So destination is 4. Next is starting time and arrival time. So this is an integer. Okay, so let us keep it as integer. You can keep it as an array also of integers. Okay, array of integers. How will it be? Arrival time of 4 and um, starting time and arrival time. Starting time of 4. Fine. Next is the number of seats. So that will be integer. So here only I can declare it, or let me call it seats. So this is my flight details. So I have defined the structure of flight details. Now I want to, inside main, I will create an array of flights. So it will be struct flight and a variable of that type. So let me say flights. Okay. So suppose I am creating a variable, an array of 10 flights. Okay. Here, before this, I need to do the first part of the question, that is to read 5 such records. Okay. So to read 5 such records, I'll write a function void read. Now see how this has changed. Just notice how this has changed with respect to the previous program. You're passing an array. Arrays are you're passing the address, right? Whenever you have an array as an argument, I do not need to return anything because I'm passing the array here and this will take care of it, right? It's an array that you're passing. So here you are declaring the array in main, and once you pass it here, whatever changes are done inside this function, these changes will be reflected inside main. Yes or no? It's an array. The same idea about arrays. Whenever you pass an array, whatever changes you're making to it will be reflected from wherever it is called. Okay. So now here will be your usual read, printf and scanf statement. So printf, enter, what is that? Starting point. But remember, there will be a loop outside this. It will be f of I dot sp, right? Individual. So for f of 0, I have to, are you getting it? For f of 0, I have to access the starting point. For a flight of f of 0, I have to access the destination, right? So it will be f of 0 or f of 1 or f of 2 dot sp. So it will be f of I dot sp, f of I dot destination. Enter destination. Then this is %d. Sorry, this is %s only. For the third one, now for this starting point, sorry, this is the starting time and this is the arrival time, st and ar. Okay, so I can say at. Let me write it at. Starting time, arrival time. Okay. So now there are four. This is 4-digit array, right? This is 24-hour clock that we have. So here again there will be a loop, right? Enter the flight starting time. Okay, so here this will be a loop. J is less than 4. This also will be a loop for I is equal to 0, I is less than n, I plus plus, for all the records that you are expecting. Right, this will be %d. We will talk about read flights. We will see whether it is working, and then I'll stop because you will have your next lecture now. Tomorrow we'll continue with this programs. Okay, f of I dot starting time. Now in this case it is integer and starting time of j, right? This will be f of I dot arrival time of j, flight arrival time, and then finally the seats. Okay, enter the seats. Enter address of f of I dot seats. Fine. So this is your function, but we have to declare I and j. Sorry. So let us call this function read flights with f and 2. Let us see whether I'm able to read 2 records. Okay, and then what I will do is I will just print flights of print f %s flights of 0 dot seats, dot starting point. Let me see. This has to be, what has to be passed? The flights array has to be passed from main, right? Flight dot c. Starting point. Let me make it all caps. So now the thing is, if I don't enter and enter, there'll be a problem. So what I will do is 0, 0, 0, 0. Okay. Number of seats, say 5, whatever. Yeah, starting point is, and then and destination is something like Kolkata or something. Anything it could be. Only thing we have to take care of this. I will tell you how to take care of that as well later on. See, now it became 22. That was the problem. Okay. So it's a, so I just to test, I just printed the starting point of the first record. So it is reading properly. Okay. That was Mumbai. Starting point of the first record was Mumbai. Okay. So this is about reading. Only thing is how to take care of this. We will see. Either we make it an character array, that will be better. Shall make it a string, so that will be better. Okay. If we make this a string, it will be better. We have said integer on a scale of this. Okay, but reading that integer, you are getting that point, right? Reading will not be possible otherwise. Reading will be difficult.
Zero would be missed out, no, if
Yes.
zero would be missed out, no, if we initialize it as integer.
So it is not a single integer. I made it an array of integers. But if I've made it an array of integers, 0, 0, 0.
Yes.
But if I do that also, I have to be careful about while entering. See, because I made a mistake while entering. So while entering, you have to be careful.
String would be better, no?
String would be better. Okay, we'll make it a string. Let it be. Okay. So this is about reading, and next thing is which I'll discuss tomorrow. That is how to take the queries of this form, starting point and destination, and then for each query you have to find match, do a match, that is string compare. Correct? String compare, and of course the seats also. Seats are available or not. Seat have to be there. Then only you can book it. Okay. So we'll continue with this example tomorrow. So that's all for today. Thank you.
मैम वो